Assalamualaikum. We are from Group Tau, Group 13. So our members consist of Nazmi, me, Angelov, Ahmad Izul and Faisal. So for this project, we have done research on SPE paper. That is, Production Enhancement Strategies for Strong Bottom Water Drive Reservoir. So, the information about this paper is water and gas conning in the oil and gas wells have become one of the major concerns in terms of oil and gas productivity. To overcome this problem, several new drilling and well completion were introduced. So the strategies for basic type of vertical well completion, there are four of them. That are partial, total, reverse, and dual penetration. There are also alternative options that are considered, such as fracturing, horizontal wells, and short radius laterals. So what is water conning? Water conning is a production problem in which gas cap or bottom water infiltrates the perforation zone in the near wellbore area and reduces oil production. Strictly a near wellbore phenomenon, it only develops once the pressure forces drawing fluids towards the wellbore to overcome the natural buoyancy forces that segregate gas and water from the oil. Important example of conning includes, there are three of them. There are production of water in an oil well with bottom water drive, production of gas in an oil well overlain by a gas cap, and production of bottom water in a gas well. So there are two types of conning. There are conning in a vertical well and conning in a horizontal well. So what is the impact of conning? There are three impacts of conning. There are increases the cost of production. The second one is reduces the depletion mechanism efficiency. And the third one is the most important, is decreases the overall recovery.
Hi, I'm Angelo. So I'll be talking about vertical well drilling. So there are four vertical well completion methods, namely partial penetration, dual penetration, total penetration, and reverse penetration. The first, partial penetration, is one of the most common perforation methods and completion methods. The perforation interval is limited, it is close to the middle of the formation, and if there happens to be a gas cap, it will be close to the top of the formation. As for dual penetration, it involves the perforation at both oil and water zones using separate production strings to maintain a pressure drawdown balance for near wellbore segregated fluid flow. The priority is to achieve near perfect radial flow at the oil zone. The perforation interval is about 10 feet, added in water layer 5 feet below WOC. The perforation interval is about 20 feet below the WOC. As for reverse penetration, it is rather a new technology that the perforation interval is in the water rather than the oil to apply a large drawdown pressure and induce oil coning. The perforation is 10 feet below the WOC. It is achieved only after a certain delay period, which a large volume of water will be produced. The well should be kept flowing to maintain the oil. So, as comparisons for the oil rates, as you can see from the graph, total penetration has the highest oil rates throughout, while partial and dual, they initially have the same oil rate, while the partial penetration will decline first. For dual penetration, it will remain its oil rate and it will act like the total penetration at later time. For reverse penetration, it yields very low oil rates initially. While the oil rate increases at time, it will not be higher, but but in the end it will not be higher than all three other methods. As for water oil rate, the partial penetration has little to very low or very low coning, but increases at time, but still lower than the others. All three of them have the same WOR and same cumulative water production. For water production, partial penetration has the lowest oil production and water production throughout, while the other three has more or less the same. As for cumulative oil production, it is the same as water production, where partial penetration will produce the lowest oil production and the other three will be more or less the same. As for WOR, as noticed in the graph, all three initially with different WOR, and then at later times they will have all the same WORs. As for reverse penetration, as stated with the definition of it, it will have a lower WOR at first and increases, but still lower than the other three. And in recent technologies, there is a way called vertical well gel treatment, where the gel treatment aims to create a vertical flow barrier that exists in certain fields, and it can suppress the bottom water breakthrough. Gel treatments are used to create an artificial vertical flow barrier, and the placement of the gel barrier is right below the perforation interval. So as in the graph, with no barrier, the delay of water coning will be very low, and with barrier, the water coning will be delayed as substantially at the time. So, but there is some challenges with this gel treatment. Firstly, it is very difficult to propagate a gel radially deep inside the formation while keeping the gel at the desired vertically small interval. As for lateral or transverse flow of gel, it will cause a severe oil zone damage. For dual fluid injection using a coil tubing and packer or bridge plug combination is recommended. A protection fluid, be it water, diesel, or crude, is pumped through the coil tubing to prevent the gel lateral flow into the upper oil zone. Lastly, it is not cost efficient. As stated here, a minimum volume to achieve a 60-foot radial penetration through a 5-foot wellbore interval and 28% porosity will be about 3,000 barrels of gel, which is a very huge number.
So hi guys, now I'm Izo. So I'm going to explain about fracture completions. So first, the fracture completion is the increased effective wellbore radius while increasing critical coning rates, and differential pressure can be reduced up to 10-fold. So vertical well with total penetrations will increase oil productions, but hugely increases water productions. So for horizontal well completions, so the objective are to improve the gas production rates, rate of recovery and project economics, just as in vertical well, although in horizontal are far more complex. So for horizontal well completions, as you can see in the slides, in the left side is horizontal well completions, and on the right side is vertical well completions. So the volume of sustained water-free production should be greater for horizontal well than for a vertical well. Eventual water breakthrough is inevitable. The ultimate recovery decreases with increased well spacing and closer proximity between the well and the oil-water contact. So, in this video is an oil rig. Oil rig is to explore, extract, store, and process petroleum and natural gas which lies in rock formation beneath the seabed. Many oil platforms will also contain facilities to accommodate their workforce. So in this video, the method that I'm using is horizontal well completions. A wellbore having a conduit disposed therein where portions of the wellbore and conduit are positioned substantially horizontally in a subterranean producing formation are provided. And then a fracture well completions. A natural fracture or there has been hydraulically fractured. The fracture is treated as a slab of high permeability that is an effective extension of the actual wellbore. Flow is from the reservoir to the fracture and through the fracture to the well. The pressure tensions analysis for a fractured well can determine the fracture half length and the fracture conductivity, as well as a fracture fast skin. The skin factor for the fracture is negative and usually ranges from -1.5 to -5, with an absolute minimum of -6 in rare cases. For effectively infinite conductivity fractures, the apparent wellbore radius is half the fracture half-length, or x, divided by 2.
Okay, next to the next closely spaced parallel and parallel lateral. Okay, first in this case, there will be risks that affect the drilling, the well that too close to the formation top. This is one of the risks, and the second risk is the gas cap will overline the oil zone, so it hard to produce the oil. Next, the net present value will determine optimal well spacing economically. Basically, to drain an area, every additional well will increase the ultimate recovery. So, as long as the incremental cost of the additional lateral is balanced by discounted incremental increase in production over time, the well spacing can be reduced until it's optimal. Next, the multilateral well drilling also save costs and reduce environmental impact than conventional well. Uh, Especially, they save costs and save environmental impact and cost of drilling. Next is dual horizontal well completion. This uh, well completion is drilled in two zones, which are oil zone and water zone. And this completion also same concept to the dual completion in the vertical well and hydraulic fracture. And this completion only can be workable if they are strong water drive. For the conclusion and recommendation, for the first one, among the four basic vertical well completion strategies, the total penetration and dual penetration methods has the most oil production and recovery, but they are at cost of handling high rate and volume of water production. And the second one, the fracture simulation of a partially completed well causes excessive water production, and it also reduces oil production. And then the third one, the layer of thickness and high horizontal to vertical permeability ratio is are the factors that affecting the horizontal well drilling. That's all from the Tau group, and thank you.